For billions of years, life on Earth operated under a strict, non-negotiable contract with the sun. Bright sunlit days, pitch black nights. This rhythmic exposure to light and dark forged a deeply synchronized internal biological clock inside almost every living thing. But over the last century, we introduced an entirely new environmental exposure: artificial light at night. We flooded our homes and cities with photons, breaking the evolutionary light-dark cycle that guided our biology for millennia. To understand what that means for our bodies, we can look at the tripartite model from chronobiologist Dr. Samer Hattar. He maps how light acts as a physical control dial for three interconnected systems: our circadian clock, sleep drive, and mood centers. When fed bright light at the wrong time, the system collapses, actively driving mood disorders, metabolic dysregulation, and impaired learning. Artificial light is a potent biological signal that rewires our physiology. To fix the resulting damage, we have to treat the photons entering our eyes as a strict 24-hour light diet. That diet starts the moment you wake up. Getting bright sunlight into your eyes allows photons to strike specialized cells in your retina called iPRGCs. iPRGCs are intrinsically photosensitive retinal ganglion cells, a specific type of neuron in the eye that detects light to regulate our biological rhythms, rather than to form visual images. These cells act as a biological sensor. When the morning light hits them, they fire an electrical signal straight into the suprachiasmatic nucleus, or SCN. The SCN is a tiny region in the brain's hypothalamus that acts as the master clock, coordinating the daily rhythms of our entire body. Here is the mathematical quirk of that master clock. It doesn't naturally run on a perfect 24-hour schedule. The average human internal clock actually runs a little long, at roughly 24.2 hours. So that morning light signal is required every single day to snap it back to the exact 24-hour rotation of the solar day. Without that daily morning photon anchor, our bodies literally drift out of sync with the planet. We end up living in a state of chronic biological jet lag, even if we never cross a time zone. The danger peaks on the other end of the day. Researchers measure the damage of evening light using the melatonin suppression value, or MSV. MSV is a specific metric that calculates exactly how profoundly different light sources halt the production of our natural sleep hormones. When we compare modern cool white LED and compact fluorescent lamps against traditional warm incandescent bulbs, a stark difference emerges. Modern cool LEDs emit a massive amount of irradiance in the short wavelength blue and cyan spectrum. This chart compares estimated melatonin suppression across lamp technologies. On the left, cool white LEDs and CFLs show dramatically higher suppression than traditional warm incandescent bulbs. The right graph shows a direct correlation. As light gets cooler, melatonin suppression skyrockets. Your brain processes that cool, blue-enriched light and assumes it is still midday. This blue light hazard is especially damaging to young children. Preschoolers have larger pupils and crystal-clear eye lenses that transmit far more light than adult eyes. As a result, standard pre-bedtime room light can trigger a near-total 90% suppression of their melatonin. By upgrading vintage Edison bulbs to modern, energy-efficient LEDs, we accidentally flooded our evening homes with a physiological daylight signal, devastating our sleep drive. If you're already sleep-deprived, the problem compounds due to something called photoperiod history. This is the concept that the total length of your nightly sleep directly alters your biological sensitivity to light over time. This is a paper by researchers Helen Burgess and Charmaine Eastman. They demonstrated that humans experiencing chronic 6-hour sleep nights show significantly reduced circadian phase delays in response to evening light compared to those sleeping 9 hours. When we constantly truncate our sleep, we cause profound biological confusion. Because we are spending more hours awake with our eyes open to the light, our bodies perceive a long summer photoperiod, regardless of what season it actually is outside. This artificially long perceived photoperiod blunts the circadian system's overall responsiveness. It makes it noticeably harder to shift our internal clocks when we actually need to adjust to a new schedule or recover from a deficit. Sleep deprivation acts as a compounding trap. By actively curtailing our sleep, we damage the exact biological mechanism our body uses to interpret light and regulate its own rhythms. Since we cannot abandon modern society and return to the Stone Age, we have to actively engineer our indoor spaces and our technology to mimic that ancestral environment. The foundation of this strategy is the morning protocol. You need to secure 10 to 30 minutes of outdoor light shortly after waking up. Even if you are standing in the shade or it's a cloudy day, the sheer volume of outdoor photons is enough to firmly anchor your circadian system. For the evening, we can deploy specific technology countermeasures. The first is utilizing tunable CCT lamps. CCT stands for Correlated Color Temperature, a scale that measures how warm or cool a light source appears. These smart lamps automatically adapt their color output to match the time of day. The data on these tunable lamps is incredibly strong. By shifting the bulb from a cool 5700 Kelvin daytime setting down to a warm 2100 Kelvin setting in the evening, you can reduce estimated melatonin suppression from 10% to just 0.1%. The second countermeasure is the use of blue light filtering lenses. But there is a crucial caveat here. The vast majority of clear, consumer-marketed computer glasses offer almost zero actual biological protection. This chart reveals the test results of various blue light filtering lenses. Looking exclusively at the far right of the box plots, you can see the results for targeted lenses that feature a heavy brown tint. These specific lenses successfully block the critical cyan wavelengths, dropping melatonin suppression and melanopic illuminance down to a harmless 0.3%. Light delivers critical biological information directly to the brain. By actively controlling the timing, wavelength, and duration of the photons entering our eyes, we can reclaim our evolutionary baseline and protect our health.